So in our yesterday class, we tried to see about image pre-processing because image pre-processing is critical for improving the quality and the naturalness of images before using them for designing a given application. And we tried to discuss about filtering techniques. There are different filtering techniques that we can use, especially in spatial domain, like the non-median filtering, mean filtering, Gaussian filtering. All of them are implemented in MATLAB. Besides that, whenever the noises are becoming more challenging, we can even convert the domain from spatial to frequency and then go for transformations like cosine transformation, Fourier transformations. Still, even if they are important for filtering, the image restoration and enhancement techniques, while they are trying to clean the image, they may drop some unwanted noises into the image, especially they may affect the structure of the image, the picture element. As a result, after applying image filtering, after applying image enhancement, we have to go for morphological analysis to analyze the structure of the picture and make a correction to the shape or structure of that image. For that, we need morphological processing, which tries to check whether foreground pixels are switched to background pixels or not, or else the background pixels are switched to foreground pixels or not. Towards checking whether there is more pixel element that are added to the foreground pixels or the background pixels. The two well-known operations of morphological processing are the dilution and the erosion. The dilution operator is trying to check whether part of the picture is switched to background or not. Erosion checks the reverse. While the pixel is part of the background, it may be added to the picture. So dilution is trying to improve picture elements, while erosion is trying to improve background. So erosion is trying to erode, reduce picture elements, and the dilution is trying to add pixels to the picture element. How they are working, especially morphological processing, is with a better performance when we use it in binary image. Say that whether it is color image or grayscale image, we have to convert it into monochrome or binary image. Say that the image has only 0 or 1. So using that 0 and 1, dilution is trying to check whether the expected 1 is converted into 0 or not. As a result, depending on the window size that we defined or the structuring element that we defined, it's trying to convert if the pixel is a picture element and based on either during digitization or filtering, if it is converted into background, it will recover it back to the foreground pixel. But when it comes to erosion, it is trying to check whether the pixel is converted into foreground while it should be background. Says that if it is 1, erosion is trying to convert it into 0. How things can be done? Since the aim of dilution is converting zeros into ones based on the structuring element evaluation. Whenever there is one pixel with one picture element or one number, then that one binary number is taken as to update the pixel as the center of that structuring or window. So we need only to see for dilution, is there any one in that given structuring element or not? That means finding the maximum number. Since we are expecting in monochrome or binary image 0 and 1, the maximum number is 1. If there is one maximum number 1, then we can take that one at least to replace the central pixel that we are evaluating whether it is a pixel representing background or foreground. The same principle can be also applicable in a grayscale image. So by evaluating using structuring element, we are trying to find the maximum value. If there is maximum value, then replace the central pixel with that maximum value. But erosion is working in a reverse direction to find the minimum value. The minimum value in binary image is 0. If there is one pixel with 0 value within the structuring elements that we are evaluating, then the central pixel is converted into 0, even if it's 1. So as a result, dilution enables to enhance the foreground or the picture element, and erosion is trying to improve the background, the place where the picture is available. So structuring element is critical for effectiveness of erosion and dilution. So the structuring elements that we defined should be experimentally checked to identify which structuring element is working better for that given image collections. They may be 100% fitting to the image, or they may be partially fitting to the image, or there is no overlap between the structuring element or the window and the original image that we are checking. So if it is fitting, then we can take 1 or 0 automatically. So that means the pixel is containing the true value, but sometimes it may be hitting, that means partially overlapping with the picture element. Then with the principle of min or max, we can identify the pixel value for diluting or eroding the central pixel that we are considering. Or if there is no overlap, so there is a miss, so then no operations performed. So see an example where we have an input image or original image, and I want to make sure that the image is with no noises added by digitization or filtering. So our structuring element is in 1 by 3 dimension. So we are fitting this structuring element at each of the pixel values within the input image. So here we are trying to dilute the image. Diluting means trying to recover the foreground pixel. If there is at least one in the structuring elements that we are considering and matching with the sequence of pixels that we are considering. Since our structuring element is here only tries to see 3 values row-wise. So if you put this structuring element on the first pixel with 1, since we have 1, 1, 1 structuring element, at least 1 is available on the central pixel, even if the right one is 1, but the input image is containing 0, and the left pixel is not aligned to any of the pixels within the input image. So since at least there is one which is matching with the input image, it has to be preserved as it is. But if you consider the next one, 0, and put the structuring element 1, 1, 1, with the central pixel, the second one, which is aligned to the pixels that we are considering. So the original input image is 1, 0, 0, but the structuring element is 1, 1, 1. So that means at least it is matching with the left pixel 1. So that means at least there is one pixel with one value. So the next pixel is also 1. Since in the dilution we are trying to select the maximum value, which is available in the input image and the matching to overlapping with the structuring element. So the second 0 is replaced by 1. If you go down to 0 also, again we are putting 1, 1, 1 on the structuring element on this point, and the 0 we are aligning the central pixel in our structuring element to the central pixel that we are considering in the input image. Then to the right direction there is 1 which is aligned to the input image 1. There is an overlap, so then this 0 is also replaced by 1. But if you go down one step, we have 0, 0. They are not overlapping with 1, 1. So then we have to preserve 0 as it is. So all below this one are 0, 0 from either side. So then we have to keep that 0. So by moving the structuring element over the image, we have to evaluate whether there is one at least pixel with one value that's matching with the structuring element within the input image. Then accordingly we can convert it into 1. Otherwise, leave whatever pixels that are available within the input image. The same thing you can do for grayscale image. But mostly morphological processing is applied for a better result in a binary image. If I apply it on grayscale image, the dilution operation of morphological processing, again, if we use the same structuring element and align that structuring element on the first pixel with value 16. So on this value 16, we are putting the structuring element, the central pixel 1, and then we have one more chance to see to the right direction. Out of the two values, the maximum one is 16. Compare 16 and the 14, because to the left direction there is no other pixel. So 16 should be preserved as it is. But if you go one step further, second column, first row, again align the structuring element by putting the central pixel in our structuring element on the pixel that we are considering. So to the left of that there is 16, to the right of 14 there is 14. Out of 16, 14, 14, the maximum value is 16. So 14 should be replaced by the maximum value in the case of dilution, 16. So if you go down 53 and bring that structuring element on 53, where the central pixel of the structuring element is lying on 53. So to the left direction, there is no element to consider or pixel to consider, but to the right direction, there is one pixel. So out of 53 and the 57, the maximum one is 57. So 53 should be replaced by 57. So that means in the case of dilution, within the given structuring element, we are trying to identify the maximum value. And that maximum value is replacing the pixels that we are considering. So in such a way, the input image is evaluated and an output is created based on the dilution. If you consider again a binary image, and if we have a 3 by 3 structuring element where we are considering cross, where ones are available vertically and horizontally. If we are aligning this 1 vertically and horizontally at every place, then there are elements that should be switched to 1. So in the meantime, the dilution is increasing. Member of the structuring, the structure of the picture. So as a result, this picture is converted into this kind of picture by aligning this structuring element at every pixel. If you align this structuring element somewhere at this point, since all around that is 0, so no overlap, so 0 is kept as it is. But if you go down around here, 0 again, and if you align the structuring element on this 0, we'll get 1 to the right direction and 1 down. Since there is 1 which is near to this 0, so the 0 should be replaced by 1, because these two are matching with the structuring element. So as a result, more picture elements are recovered from the picture, and as a result of which the foreground or the pixel, the picture elements are more magnified. So it is enhancing or it is enlarging the picture element. So the picture becomes more smooth. So it's reducing background and it's increasing the foreground. Especially as you are increasing the size of the structuring element, the effect of dilution is also increasing. As a result, experimentally, we have to identify an optimal structuring element. Mostly, there are historical documents, even in our country, which are archived by digitization. But those historical elements are, historical documents are poor in quality. Especially, the original document by itself is losing its quality and naturalness. If you see E and A, which are available in year, there are discontinuities in E and A. So sometimes it's very difficult to read them. So there is a need to fill those discontinuities. To fill those discontinuities, we have to go for dilution. So by running over all the image, so finally it has to connect the disconnected part of the image. So especially for historical document, to recover back their original quality, such kinds of morphological analysis are critical. On the other side, maybe there are inks that are filling the picture element. While you are expecting open space, maybe that open space is filled by ink or once, as a result of which maybe it's not readable. So that means we have to remove whatever additional pixel elements that are added to the picture element. In such a case, we need erosion. Erosion is trying to improve the quality of the picture element by reducing those incorrectly imposed, by deleting those incorrectly imposed picture element. So it's converting ones into zeros. That's why it's called erosion. So erosion is reducing the picture element and increasing the background. So the foreground is decreased. if you are using the same structuring element, and if you run it, that structuring element over all the pixels, and whenever there is at least 1 0, then that pixel point is converted into 0. Because we need a minimum element in the case of erosion. If there is one minimum element in the binary case 0, then that pixel point is converted into 0. As a result, those blobs appearing in a given point can easily be removed, so that the picture can be with a better naturalness. So by applying erosion as compared to dilution, it is shrinking foreground and enlarging background. But to what extent it enlarges background depends on the structuring element. As structuring element with more pixels are taken, as the size of the structuring element increases, since it is trying to investigate large space, erosion is greatly applied, says that most of the picture elements may be converted into background. As a result, again, when we are applying erosion or dilution, we have to make sure that we are using an optimal structuring element or window or mask. So this is your digital image processing project. Already we created a group, and for each group already tasks are assigned. What's expected is using the given combination of filtering techniques, take different document. Again, the documents are also attached, but you can take also other document if you can get it easily. Then finally, after testing, you have to identify the optimal either one filtering technique or a combination of filtering techniques. Mostly we have to identify a combination of filtering techniques. When we are identifying, maybe we have to add more noise, or maybe we are expected to binarize the image as per the given instruction. Finally, you are expected to produce a report with this kind of format. A report with an abstract, a report with statement of the problem, what you are investigating, what do you want to explore, and then a description of the algorithms that you are using, how they are working, why we need them. Then finally, experimental result with objective measures like SME. There are different objective measurement techniques. So using those objective measurement techniques, you have to select the one which is better improving the quality and the naturalness of the image. Finally, based on the experimental result, you have to discuss the strengths and the weakness, the problems that are happening. Finally, your conclusion in terms of strengths and weakness of the work, and the one recommendation at the future work. And don't forget reference by using one of the referencing style that you are preferring always. So the other part is image analysis. Because in image application, we have 3 major steps. The first step is image pre-processing, where we are improving the quality of the image. The input is image, the output is also image. But the difference between the input image and the output image for image pre-processing is we have a better quality and a naturalness image at the end. And that image with a better quality and the naturalness passes through image analysis. Why we need image analysis? To identify picture element and then represent that picture with descriptors or representers or features. So image analysis is converting an image into a sequence of numeric values that are representing the picture element. Nowadays, if you are using deep learning, you may not need segmentation and the feature extraction. But for a better result, again, we need it. So we have to decide experimentally by segmenting and identifying the picture element and giving it to the CNN classifier, or else without segmenting by giving it to the CNN classifier. But the problem is maybe there is a mismatch between two images with the same background, especially. Again, a feature extraction, we can extract, and we can also allow CNN to extract. Which one works better? Again, it depends on the image type that we are analyzing. So experimentation is critical in digital image processing and machine learning. So what's image segmentation? Image segmentation is identifying the picture, the foreground from that given image. There may be multiple images within an image, or there may be only one picture within the image. At least we have to, if there is one image only, at least we have to separate the foreground from the background, such that the application becomes more effective. It can deal only with the picture element. We can make our system scalable, even if the size of the image is increasing. And we can also increase the effectiveness of the system because it concentrates on the future extraction of the picture element only. So segmentation is critical. The major goal of segmentation is identifying the different regions of that image based on the similarity of the regions. So given an image, you may get n sub-images within that image. So partitioning it into different parts is the responsibility of segmentation. How we can segment? There are different algorithms, either edge-based or region-based. Just by looking at the structure, the shape of the image, or else by going deeper to the content of the image, and by looking at to what extent pixel elements are similar with each other. So image segmentation for the given image R, it gives us n subregions of that original image R. But those different n sub-pictures identified from the image has some properties, like all the pixels within RIs are similar with each other. They are representing the same image. And take R1, R1 is different from R2. There is no intersection between R1 and R2. So in general, a given R1 is connected with each other. So there is no discontinuities. But the combination of all R1 up to Rn will give us the original image R. So we are trying to identify pixels in that given image, and as per their relationship, we are trying to identify those sub-images which are related with each other using image segmentation. In general, we have two approaches in image segmentation: region-based segmentation and edge-based segmentation. Because either we can, during segmentation, we can see the similarity of the pixels or the similarity of intensities, the spatial distribution within the image, or else we can see the structural combination of two or more images. Whenever there is discontinuities, we can assume that one image which is available within the whole image is different from the other image which is available in that given image. So we can identify easily the sub-image within the image by discontinuities. When you are writing, each characters are separated from each other. Each words are separated from each other. Each lines are separated from each other. That discontinuity can be used for identifying from image characters, words, lines, paragraphs. The same thing in different picture elements that are available in a given image. Maybe the image is containing sky, river, grass, human beings or animals. We want to identify all the elements that are available within the image. So by following the discontinuities, we can still identify. But the problem of edge-based is, what if there is a noise that disconnects them, that fills them? Either it is trying to partition the same image, which are representing one image within the image into multiple images, if there is discontinuities. And also if they are connected, while they are different sub-images, the edge-based segmentation may make them as one image or consider them as one image. So in a noisy image with less quality, naturalness image, edge-based may not be effective. But when it comes to region-based, they are more effective with some tolerance by looking at the similarity between pixels, their intensities, and the spatial distribution. We can identify one sub-image from another sub-image which exists within the same image. So nowadays, region-based is getting more popular for image segmentation. There are different algorithms that are available. But in a region-based segmentation, the major steps taken are just it is trying to compare pixel by pixel. Says that it is trying to bring together all those pixels similar with each other or near to each other. Then if the pixels are far from each other or different from each other, based on their intensities, based on their values, then accordingly they are grouped into different sub-images. Finally, those pixels with the same labels are representing one sub-image. Those pixels which are represented or labeled by another label are considered as part of different sub-image within the image. So one of nowadays the popular technique is region growing. The name itself is region growing. Starting from one pixel, it is trying to grow further to identify more pixels which are similar with the pixel that we are considering. So through exploring different pixels, then it is trying to identify pixels that are representing a given subregions within the image. Finally, it is trying to aggregate those pixels starting from a given seed point. Then those similar pixels with that seed points are identified by considering again the neighboring pixels or the nearby pixels. Every time it's moving around in a 3x3 window or in a 5x5 window or in a 7x7 window. Finally, it's trying to identify those pixels which are representing the same image. The issue here is, one, where can we start within the image? What is that seed point, the starting point? The other thing is, what does near means? How can you say this pixel is near to this pixel? What kind of cutoff point we have to use? Again, these things are left for experimentation. We have to experiment and identify where to start and how to consider 2 or more pixels similar with each other. So mostly digital image processing is an experimental research. So if 2 or more pixels are similar, means less than or equal to the given cutoff point, we can say they are part of the same subregion. But if the intensity of 2 pixels are greater than the given threshold value, we can say that they are not similar, they are part of different subregions. For example, given this image, 7 by 7 image, and we can go for considering either by using a 3 by 3 window or by drawing a cross window or a multiplication sign window that considers either diagonal or horizontal vertical or box, all directions given the central pixel. So one of the issues is where to start. Mostly, most algorithms are suggesting to start from the central pixel within the image. Then from the central pixel, the subregions has to be identified by relating different pixels that are related to the central pixels. And then connectivity is increasing from one pixel as we proceed to the other pixel. So for the time being, we can use, even if it is decided through experiment, the threshold values that we have to use to say these 2 pixels are similar or not. For the time being, we can use if 2 pixels has a difference less than or equal to 5, we can consider them as 1 pixel. So depending on the number of connectivities that we are considering, the number of similar pixels that we are identifying is also different. As the number of connectivities that we are considering increases, the similarity between pixels also increases. Just let's consider the 4 connectivity. The 4 connectivity means just by